Welcome back, friends, to lesson number 3 of our algebra unit. Today we're going to be talking about taking our algebraic expressions and actually evaluating them. When I get into the lesson, trust me, you're going to find out how really straightforward this lesson is in comparison to lesson number 2. But that's just my opinion. So let's get started. Now, before I get into today's lesson, I thought that we'd spend some time actually practicing what we did in lesson 2. So in lesson 2, I had a word problem, and we had to figure out which algebraic expression actually went along with the word problem, and that's what I have here. So I have a straight word problem here. I'm going to ask that you pause it and see if you can figure out which of these algebraic expressions would help you actually solve the word problem. So let's go through it together. So we have here, M. Prasad plans to hold a party for a group of her friends. The cost of renting a room is $25. The cost of food is $3 per person. Which algebraic expression gives the total cost in dollars for the party for n number of people? So go ahead, pause the video right here and see if you can figure out which of these 4 equations would actually help you solve it. All right, I'm back. Do you have the answer? Let's go through it together. Now, I find the best way to do any word problem is to actually take the bits and pieces that are there and see if we can figure out which parts are really necessary. So let's go through. Now, I tend to zone in on anything with numbers into it, but that's just me. I find that's a good place to start. So I see $25 here, and I see here the cost of renting the room is $25. So I know that number here has to be there somewhere. So I'm going to circle that one, leave it in the back of my head somewhere. Now I remember when I was going through this, there's another part here. It's telling you the cost of food is $3 per person. So now that section right there is very good for me to understand, because if I'm looking for a variable, I know that n will be somewhere around here because I don't know the number of people that are going to be at the party. So that's how I would figure out how much it would actually cost. Once I had the number of people that are in the party, I would multiply that by 3, and then I would figure out that's how much it's going to cost me. So if I go through down here, I'm going to start with that one. I'm going to look for 3, and I'm going to look for anything that's multiplied by the variable. So I see, if I go through it, actually the only one that falls into play is the last one here. So let's go through and explore that one. So if I go back to the beginning again, the cost is $3 per person. So to figure out the actual cost of this party, we take 3 multiplied by the number of people. That's what I have here. And then I'm renting a room for $25. So I'm just going to add that on to the end here. And that's exactly what I have. So then, which means all those other options here would not help me answer the question. Did you get it? Good for you. Now let's get into the actual evaluating an algebraic expression. So when we are evaluating an algebraic expression, we're taking the variable and we're actually going to be replacing it by any sort of specified number. So in this example here, I have 2 algebraic expressions and I have the variable, and I'm going to tell you what to replace the variable with. So let's get started with the first example here, and I have it here. So I have here 5k plus 2. So they're going to ask us to evaluate that algebraic expression. Now the really important thing here to pay attention to is k equals 3. And how you do that, what it means, is that wherever I see k in my algebraic expression, I'm going to replace it with 3. Really, really important. Now I always tell my students, make sure that your first line is always going to be the actual expression. So I'm going to leave everything there and I'm going to do my work right underneath it. So I'm going to put my equal sign here. Now I'm going to rewrite the equation, and this time I'm going to take that k and replace it with 3. 3 plus 2. Now I did something here, and again I'm hoping that you remember that when you have a variable and a number side by side, that there's a multiplication in there. And I just put the 3 in brackets to help us remember. I didn't actually have to do that. I could have taken that and I could have also written the expression like this. Either way, I'd be completely fine. Now let's go through and actually solve it. Now if you remember our BEDMAS, B-E-D-M-A-S, I would actually solve the multiplication first. So last time I checked, 5 times 3 is 15, so we have that down. And then I'm going to bring my 2 down because I didn't use it. And my final answer is going to be, 17. I'm going to circle my answer. And here's the other example that I've also wrote down, and that would show up in the textbook that we actually use. So let's go ahead and let's do another example. This one's a little bit more tricky. Now you got to be very careful and pay attention. I have x minus 3, and I have that slant and a 5. Now what I want you to remember is that whenever you see that, you have to think divided by. So we're going to take x minus 3 and we're going to divide it by 5, and in this case x is going to stand for 13. And I've rewritten it a little bit nicer over here so that you would understand that slant actually stands for division. So again, I'm going to keep this in brackets. So x stands for 13, so 13 minus 3. And then I'm going to divide that by 5. I'm going to put my equal sign here. So I've set everything up. X is 13. I rewrote the algebraic expression and I substituted the variable for whatever that number is. So I have here 13 minus 3 divided by 5. So again, we have to remember BEDMAS, and if we remember that, anything within brackets is done first, which means I'm first going to take care of the top, which is 13 minus 3, and that one gives me 10. Divide that by 5. Again, if you remember what we said about BEDMAS, it's one operation per line. Even though it would have been very easy for me to jump here to the answer, I don't want you doing that. Show every single step along the way. 10 divided by 5 is 2. Final answer. I always encourage students to circle the final answer. I've said it in my previous videos. It helps the teacher see what your final answer is, and anything above is your work, which helps back up what you said. And what you have here is your actual work shown exactly the same way as what we just did together. Now, usually when you have algebra, we like to put it within context of an actual patterning. And I haven't done that yet. I was saving that for a little bit later, but I thought I would bring that forward because sometimes when you are asked to evaluate an expression, they always want you to put it within context of patterning. So in this case, what we're asking you to do is to take the algebraic expression of 3n plus 2, and then that variable n, you're going to replace it with each of these numbers here, and then you're going to get an actual table. And let me show you what we have here. So if you think back into grade 6, you would have done input-output tables, and this is how they would have been set up. The only difference now in grade 7 is I've taken an algebraic equation, and I'm actually going to use it to help me calculate the output. So I've actually the work has already been done here. We're just going to go through and understand how they actually use the input and put it into the algebraic expression in order to create the output. So I have the table here, and I'm going to bring up in a couple of minutes, or I should say a couple of seconds actually, I'm going to show you how we're going to replace the variable with 1 and 2 in order to get the answers of 5 and 8. So I'm going to give you a little bit of a minute. Well, actually, let's go through it together and we'll see if we understand what was done here. So I held the algebraic expression 3n plus 2, and if you remember what I just finished saying, when we are evaluating and solving the actual algebraic expressions, we're going to take the variable and replace it with whatever number we're told. So here we're being told the input is going to be 1. So that equation would be rewritten, and whenever there's an n, we're going to put a 1. So 3 times 1 plus 2. Remember the BEDMAS, and the rest of it will be solved exactly as we typically would, and we would get the answer of 5, and that's exactly what we have in the chart. So let's go on and do the next one. So in the next example, our variable is now going to be 2. Let's go through. So again, 3n plus 2. We're going to write the equation, take the n, and substitute it for 2. So 3 times 2 plus 2. Remember, bad math, fill it through, and we get an answer of 8. And that's here as well. Now let's do an example together. You and I are going to do 3, and if we do it properly, we should be getting the answer of 11. All right. I'm going to write down first here the formula. I always write down the formula first. That is the expression. We always write that down first, and then afterwards, when we do the substitution, then we put that in as our second line. So let's do that one together. So we go 3, and if I remember, when my variable and the number are side by side, I'm doing multiplication. So 3 times 3 plus my 2. So again, I took my variable and replaced it by 3. So I have 3 times 3 plus 2. I'm going to put this through BEDMAS. So when I put it through BEDMAS, I know I have to do the multiplication first. So now I have 9 plus 2. And my final answer will be 11, circled. And there I go. 11 is here, and that's exactly what I wanted. So there you go, friends. That's how you actually evaluate algebraic expressions. Just remember, you're always looking for the variable, and with this particular exercise, we'll actually tell you what number to substitute that variable with. So you're always looking for that. So now you'll be able to put it in context of patterning, input-output table, or you'll be able to do it within a word problem, or think back to just some of the other questions that we've been doing back here together. So good luck, and we'll see you in the next video.